Welcome to Study Loop.
This is the answer to Chapter 13, problem number 19 from the Smith Organic Chemistry textbook. And this problem asks us to consider oleic acid, which is a common unsaturated fatty acid. And we're asked what are the major IR absorptions in the functional group region for oleic acid. And so we're given this, unfortunately, as a ball and stick model. So the very first thing to do, I think, is to redraw this as a skeletal model so that it's much easier to see what's going on. Ball and stick models are great when you can manipulate them in 3 dimensions, like in a computer modeling program or something. But on a piece of paper, they are, or on, frozen on a screen, they are, in my opinion, very difficult to work with. So I redrew this. I would encourage you to do the same. And so having redrawn this, we can now assess what our functional groups, what our absorptions are going to be. So we have a lot of CsP3 hybridized carbons bound to hydrogens. So we're going to have a lot of absorptions for that. We also have a carbon-carbon double bond. And so since there are hydrogens on these carbons, we are going to have CsP2 hydrogen, or CsP2 carbons. So sp2 carbons bound to hydrogens. So we're going to have signals for that. Apologize. So we also have this carbon double bound to an oxygen. So we'll have a signal for that. And then also we're going to have this OH stretch from this OH group. And so this is going to be higher and broader than a typical OH because it's a carboxylic acid and not just an alcohol. So we can take these one at a time now that we've identified what we have and just identify where we would expect those peaks to be. So the CsP3H is going to show at 3,000 to 2,800, or to 2,850 rather, 3,000 to 2,850 wave number. Okay. So next, our carbon-carbon double bond is going to show at 1,650 wave number. Okay. And so our CsP2H bond is going to show at 3,150 to 3,000. Okay. And then we have our carbon double bound to an oxygen. And so that is going to show at about 1,700. Okay. And then so lastly, we have this OH stretch that I talked about a little bit already. And so that is going to show somewhere above 3,000. So we'll say greater than 3,000. And we'll learn later in the chapter specifically about carboxylic acids that the IR of a carboxylic acid OH, like I said, is broader and occurs a little differently than just the OH stretch we would expect from a typical alcohol. But yeah, so we identified 5 different types of bonds that are going to give rise to signals. So I marked them in red. And then in green below this molecule, I've identified where we would expect each of those IR peaks to show. And so that's really the only way to approach this problem. You need to identify what you have and then identify where you're going to look for those peaks. And that's the answer to Chapter 13, problem number 19.